Bismillahirrahmanirrahim. Assalamu alaikum. My name is Mohammad Asim. I'm working as DevOps engineer. Guys, in this video, I'm going to show you how we can set up the highly available infrastructure on AWS. So in this video, we are going to use IAC infrastructure as code, and we are going to use Terraform to build highly available VPC. And in that particular VPC, we are going to use Terraform management module to deploy EKS cluster. So guys, let's begin. What I have done, I've created a repository for you guys, AWS case blueprints, and I've added a little readme MD. And what you need to do, simply navigate to this section, clone this guy, and I already done that in my container. So if I do ls, you can see. So let's do the first step. We are going to discuss. There are a lot of steps I've done, in the past as well. We're going to set up VPC first, and if I do navigate to the AWS EKS blueprints, here we have Terraform and VPC, right? So if I do ls here, you can see backend TF, main TF, output provider variable and version.tf. So I will be discussing this. So first of all, what we are going to do, we are going to run these particular commands. And first of all, init do init, and we are going to discuss the stuff regarding the backend. So guys, what I have done, I've created this bucket as my backend, and I mean, what you need to do, also enable the versioning. So let me update that command as well to make sure we should have version on that particular bucket low. Let me fix this to add this particular command. So guys, what I've done, I have added a command and push my changes to my repo. So this is how you should enable the versioning on your backend, right? And what we have done, we have actually run this particular command Terraform init. So it has done the initialization step. Then we are going to do, we are going to run this particular command Terraform validate. So let's run that. It is going to validate the code, and there are other commands which I would like to add regarding the, regarding the format. So let's do that. Let it finish and let's see what happened. Till then, what I'm going to do, I'm going to open this in another tab, right? And we are going to discuss this stuff regarding the VPC. So first of all, backend 30th. So guys, for the highly available infrastructure and production ready stuff, that is how we set up our backend. So this is the bucket which I have already created. Right, definitely, if you have multiple teams or multiple members in the team, you can enable the DynamoDB table, all right, to unlock the or log the state file, backend state file, make sure it you can avoid conflicts, right? So this is the reason USC is one, and this is the key which we are going to which is going to be automatically created regarding this VPC, right? So let's see what configuration seems to be valid, and the other command is Terraform fmt dash dash recursive. Okay, so what it has done locally, if you see, navigate to VPC, uh, some of the stuff which it has updated in the backend and main tier. The format is now pretty much okay. I mean, inline, you see the equal to stuff. It is going to automatically update if you use the recursive flag with that. So we have done that, and okay, the other command we would like to add regarding the, I mean, okay, we are discussing VPC and main tier. So another command is going to be the Terraform plan. So let's run that Terraform plan, and we will be discussing uh, what are the next steps regarding the main TF. Because I've set up the local cluster name, I did the same name, I mean Cloud Geeks EKS Dev. So definitely you can use your own name. So this is actually the cluster name I've added here, and this cluster name, I mean, I'm going to add as a VPC name here, because this is the managed module available. I mean, remotely on the Terraform registry. You can simply, I've added all the links here. You can simply visit this link and see. Definitely, this is not the latest version. This is pretty much stable. I've used that version, and you can use the latest version with more feature. You can check that as well. But what we need to have like a side range 10.60.0.0/16. We need multiple AZs, so I've added those. Private subnets, public subnet CIDRs I've added, right, and database subnets. Definitely, you can narrow it down if you want more IPs. You can, I mean, narrow these down to /18, 19, up to you. But this is the demo, so I mean, it would be these many IPs would be enough. So, and also I've my public IP launch to, which means that in public subnet, if any machine is launched, it will have automatically IP assigned to that. Enable net gateway to a single net pay to, because it is going to be too much costly. Although if you want tremendously highly available setup, but it is going to be costly. One NAT gateway is more than enough because the NAT gateway definitely is going to cost more. So that's why single NAT gateway I'm using here. Create a database subnet group. How, what would be the name of the database subnets and route table for that, and internet gateway route set to false means definitely we have set up the NAT gateway, and all the traffic is going to be if it is heading toward the internet is going to go through that particular NAT gateway, right? And this is the database NAT gateway route to true. That's what we have discussed. So enable DS hostname and DNS support set to true, and the private subnet tags. This is the stuff regarding the tagging, which I've covered in past regarding the Kubernetes, um, I mean, ALB load balancer controller along with that Carpenter setup. But this is out of the scope of this video, right? So let's navigate back to this section. And now what we are going to do, we are going to do Terraform apply dash auto dash approve, right? So let it done. Once it's completed, I will be back with you guys and will show you the VPC created, right? So guys, our VPC has been set up. Let me show you the stuff, what we have in the other files. So we have discussed the main TF, nothing I added in the variables TF. If you want some modification, definitely you can do that, but this is out of the scope of this video. Origin.tf, right, greater than required version. So I've added the latest version of Terraform, right? And in the last VPC output, I'm outputting all the output of VPC. That is why using a lot of stuff here. So you will get a better understanding what is the output of that particular module, which you include everything, I mean, regarding this particular VPC. So if you simply navigate to this section and from here, you put a VPC. So this is the custom VPC which we need to do, or I mean, which we need to deploy in order to deploy our EKS cluster, right? So now what we are going to do, we are going to set up the EKS in our custom VPC. So, and that particular EKS cluster is going to be highly available. So let me navigate to this section of Terraform, right? And in the last, I'm going to show you the state files as well. So let's do that. So, okay, what I'm going to do, if I do ls here, let me do, okay, let me do cd into that particular directory, right? So if I do navigate to EKS and if I do ls here, so let's do, I mean, run the particular commands which we already have discussed. And from here, what we are going to do, we are going to do first initialize what it does. it is going to download remote modules locally, right? And it is going to create a small directory .terraform. So if I navigate to this section, let me show you what we have discussed. Just like in VPC, you see this .terraform directory and EKS. Now it has downloading actually the remote modules locally, right? So it will take some time, guys. So what we are going to do, we are going to wait for a while, let it download. Then we are going to do validate, plan. Until then, what I'm going to do, we are going to do backend stuff. So backend.tf. So in backend.tf, I'm going to, I mean, uh, chopping my backend state file into chunks because it is going to be in the best practices that you should divide your sources in multiple state file rather than a single state file because in future management is going to be much more easier and it is best like if you want to deploy or add new resources that Terraform plan apply will take a lot of time. So and if that particular state file is corrupted, you will find a lot of issues. So that is how we can divide that particular backend state file into multiple chunks regarding our resources. So guys, what I'm going to do, I'm going to um, add, a different key to our EKS cluster. So previously we have dev VPC. Now we are going to add dev EKS Terraform state, right? So this is regarding the backend state file. So then okay, discuss versions.tf. So version.tf is exactly the same, and currently we don't have anything in the variables. If we want, want to override the variables, uh, we can do that, but this is out of the scope of this video. So it is exactly the same file regarding the provider.tf. We are going to use HashiCorp and like kubectl, we need that particular provider Helm and provider AWS. That EKS main .df is quite a bit lengthy, so we are actually outputting the stuff regarding the module and Kubernetes add-ons, just like we have done for the our VPC, right? So let's discuss this file. Till then, let it download. You see, this is quite a big module, right? So, okay. So what we are doing here, we are first of all, fetching the data from the Terraform remote state file. I mean, of of our VPC, right? So backend state file is in the S3, right? So this is the backend state file where we need to fetch the data regarding the VPC output, which I've already shown you in the Terraform output. So I've set up the locals, right? And the cluster name is this, and we are going to deploy the latest offering from the AWS EKS. So this is also a managed module, right? So guys, I'm calling this module EKS, and this is the version which we are using. Definitely, you can check the latest version with new features as well. So cluster name is which you already shown you in the cluster version. VPC ID, which we are actually going to fetch from the VPC module, which we have deployed. Subnet IDs are going to be three subnet IDs in multiple AGs. So that is how our IKS cluster is going to be highly available. Like when it deploys the nodes, it will deploy in multiple AGs. And if one node goes down, we have, if one AZ goes down, in which we have multiple data centers. So uh, we should have, highly available setup as well. Like the other VPC is deployed in US East 1B, US East 1C. So I'm assuming that if US East 1A goes down, so that is how we get highly available infrastructure. Definitely, you can do the pod, NT-FNT as well regarding the high availability to make sure every pod is has do not tightly coupled. You can do that to Kubernetes as well, right? So now we have uh, enable IRSA is the OIDC we are enabling for authentication. If, for instance, if you want to have like service account to enable to authenticate with Kubernetes OpenID Connect, we can we need to enable this, right? So private access and public access true. So it's pretty much self-explanatory. So I mean, from public we can access our cluster publicly without having any access, and publicly and privately we can, if we have VPN set up in our, VPC, we can, I mean, attach our machines with that particular subnet and enable that, access that particular cluster to make API calls to that particular cluster. If you want private access, simply disable this. You need to set up VPN to get extra layer of security. You can do that as well, right? Or you can set up like, bastion hosts or machines to access that particular cluster. So cluster adds on Code DNS proxy. You can we have added is pretty much available. All the stuff with detail regarding this, is available on that particular link. I've added all the stuff. Definitely, it is not possible to cover every step. So we these are the security group additional rule which we need to add for further regarding the carpenter. Which I've covered in my previous videos. I've set up that, added those ingress rule between cluster master and worker nodes, right? So anyway, let us scroll down and some of the other stuff which I should show you guys. These are the, cluster security groups, node group is automatically will be available, and you need to have tags as well, which I've already discussed in the regarding the carpenter. If you want to set up that, the security group should have these tags. So it is going to automatically done. We don't have to do much regarding that. Then we are going to create, manage node groups. Till then, let's see if everything is initialized. What we're going to do, we are going to validate and plan. Let's validate, and then we are going to do, I guess, leave the plan to make sure this video will not be very long. So, okay, on manage node group, we are going to set min and max size. So on-demand nodes to make sure that our, major application like ELB, ingress controller should be highly available on on-demand nodes. I added a node group regarding the spot node as well for, cost effectiveness. We can do that as well. So these are the policies needed. Uh, I mean, regarding that as well. CSI controller to driver. So container storage interface for EBS volumes to provision. You need to make sure that we should have these policies, available, right? So I've added those additional rules. And also here last tab two and instance type, definitely I'm using the, minimum cost effective machines, but definitely not recommended these in production environment. You can test set up uh, these because these are CPU burstable nodes, right? So enable monitoring and ABS optimized true. These are the block mappings, and definitely you can manage, update the size and IOPS to your environment needs, right? These are the stuff which is required regarding the carpenter. So just I'm putting that as well. So regarding the spot nodes, min size are I set to 0, desired set to 0, because I'm going to only provision here the on-demand nodes because of my type of, I am using the sandbox environment. It has some limitations, so definitely you can um, update this to your spot nodes, and definitely you can add taints and tolerations regarding the spot nodes. So, but I'm not applying any taints and toleration on that. So, okay. So there is option to set up taints as well. Definitely, I cannot cover everything here, but definitely you can, along with labels, you can add taints. You need to navigate to that particular link which I've read it. This node group will automatically have taints, and in deployment you can add those tolerations. So EKS admin group, I mean, it is going to all automatically create the EKS admin group uh, in the, I mean, your in the IAM section, right? And IAM policy, which we need to do. Uh, and by creating this, it will give you leverage that simply you need to add the user on that particular group, and those users will have admin access. And I'm going to also create a one developer group which can have, I mean, read only access. So it will create that particular IAM group. So you simply need to manually add that particular users from the UI. You can do that. Detailed video regarding that I've already covered in past, so I'm actually giving more detail here. So run the Terraform auto approve apply. So what it does, it is going to create EKS cluster with 3 nodes, and also I'm going to show you the backend. So this is the developer group, and we are going to attach the ARN, and it is going to automatically update the EKS auth regarding that. So I mean, yeah, Kubernetes provider. This is the Kubernetes provider. So we need to have, like, in order to, I mean, pass these arguments regarding the cluster name and profile to default. This profile default is actually our current default profile, which we are actually using here in order to deploy this. So this is what is talking about here, right? So previously, it has some issues which I've debugged and search. I did the links as well. So this profile default is actually your AWS default profile. If you're using a different profile, like, I mean, like a dev profile or your name like Asim profile, you need to update this section, right? So, and these are the EKS glue print adds on, for instance, adds on. Previously, we deploy a load balancer controller through Helm chart. If you don't want to do that, this module automatically do that for you. Simply, you need to add true here. Matrix server by default, EKS not offer. Matrix server, it is going to automatically available. Definitely, if you are using Carpenter, you should disable this or I mean, set to false cluster autoscaler. We don't need it. And if you enable the Carpenter. So Carpenter, as I discussed, this is not the topic, and because it is already I discussed, and it is quite a bit longer topic. So I've covered that in my other videos. You can do that. You can watch those particular video, right? So Helm is the one which we need to have to deploy all these resources automatically done for us. So that is the main stuff regarding the EKS main TF. So output TF, I've already just discussed provider.tf, and if I navigate to this section, let it deploy. I will be back with you guys shortly. So guys, our infrastructure is deployed, and let me navigate to the S3 section and EKS section. So if I navigate to this S3 section, you will see our two states file are going to be living. And if I navigate to this EKS section, Elastic Kubernetes, you will see our cluster with the latest version 1.30 is going to be available. So let me open the EC2 section as well, where you will be seeing that I mean, 3 nodes in highly available manner, right? So if you navigate to the bucket section, let me scroll it down. Click this guy, you will find a directory which we added as a suffix, or I mean, sorry, is a prefix. So dev Cloud Geeks dev VPC, and the other is EKS1, right? So this dev EKS state file living separately. And then we have this cluster 1.30. And if I navigate to this section, EC2, you will see that every node is going to be highly available in a separate subnet is going to be deployed. So that is it, guys. If you like the video, please like, share, and subscribe the channel. And let me show you the stuff regarding the three nodes. So if you click this guy and if you scroll it down regarding what subnet it is using, so you need to simply scroll it down, and this is the VPC ID you see, and this is the subnet US East 1C, and just simply scroll up, remove this guy. Let me add this guy. This is the container, guys, so that's why we have some, scrolling. So this is the US East 1B second node, and remove this guy, and this is the third node. It should be in US East 1A, right? So scroll it down, scroll up, and let me. This is the actually AMI ID. So this is the private US East 1A. That is it, guys. If you like the video, please like, share, and subscribe the channel, and have a nice day.